Okay, this video is just going to be a brief video about absolute value functions and their transformations. Right, so real quick, if you didn't already know, um, every type of function in mathematics and algebra has what's called a parent function, right? And the parent function for absolute value functions is this guy right here. It's just the simplest version of that function possible. That's what a parent function is, right? So this would be the parent function. This is the OG function, the most basic. Everything else that you do to change absolute value of x becomes what's called a transformation. So for example, if I said instead, f is equal to 2 times the absolute value of x minus 1 plus 7. So real quick, let's draw what the OG looks like. So the OG would look just like this, if I cannot be stupid. So let's go ahead and do that in blue. So OG function is going to look like this. The transformed function, this guy right here, however, is going to shift over to the right by 1 and up by 7. It's going to be right here, and it's going to open up a little skinnier because we have what's called a vertical stretch, right? So let's talk about just what the heck I'm saying. Okay, so the changes that we made a second ago were all simply due to A, B, C, and D that we see here, this generalization, right? And they can be summarized accordingly. So, for example, A is our vertical stretch. Okay, it also is our reflection across the x-axis. And this happens whenever A is less than 0, right? So if A is negative, we get a reflection across the x-axis. So what that means is normally we open up, right? But if A is negative, we would open down instead. Okay, so that would be a reflection across the x-axis. B is our horizontal stretch or shrink, right? And we'll see an example of what both of these look like. Okay, C is our horizontal translation. That means we're just moving either left or right, and I'll go ahead and give you a generalization here. When we add, we move left. When we're subtracting, we move to the right. You'll see what I mean again here in a second. And right here, D, and I forgot to be coloring these as I went. So C was purple or pink or whatever color that is. And D is orange. Okay, and that shifts us either up or down. So that just means if we add, we go up. If we subtract, we go down. Okay, so now let's look at exactly what I'm trying to get at here. So let me use my mouse because the stylus is kind of crappy sometimes. So here we have that same generalization. And right now, and I'll go ahead and do this separate. So this is the OG parent function. So just absolute value of x. Oh yeah, no, that's fine. Just do it in the exact same color, Desmos. That's brilliant. Let's do it not in the same color, you genius. Anyway, so this is our OG parent function. I'm going to leave this here as a frame of reference. And in blue, we're going to see how the transformations are working. So let's start with A, which is supposed to be vertical stretch or shrink. So as A increases, we see that we get skinnier relative to the parent function. As A decreases, especially in between 0 and 1, we see that we get flatter horizontally. Okay, so this would be considered vertical shrink, right? When A is greater than 1, we say vertical stretch is the generalization that we would make. So let's go ahead and include that in our little side notes here. So in green, I'm just going to put, so we know when A is less than 0, A is negative. That means we get a reflection, right? Now, vertical stretch is when A is greater than 1. and we're talking about the magnitude of A is greater than 1. So positive or negative, if A's magnitude, absolute value, is greater than 1, we're going to get a stretch. We're going to get skinnier. But a shrink is whenever the magnitude of A is in between 0 and in between 1, right? So in between, so basically if A is some kind of a decimal or a fraction, right? That means that we're going to get open wider. We're going to have vertical shrink instead of stretch. Okay? So back to our visual. So now we saw, A is greater than 1, right? We get stretched vertically skinnier. You can imagine that it's being pulled upward. And then when we get in between 0 and 1, we start to flatten out. What happens when A is negative? It's supposed to reflect, right? And that's exactly what we see happen. It reflected across the x-axis. Remember, this green is our parent function. This is what the OG looks like, right? And if I play it back and forth as we go above, right, we get skinnier, right? When A is in between 0 and 1, we get closer to the x-axis, we shrink. Okay, so I'm going to default this back to 1. Okay, and now let's look at B. So what about B? Well, B is supposed to be horizontal stretch or shrink, and we see B does pretty much the exact same thing that A does, right? So not too crazy. Now, what happens when B is negative? Well, how come we're not reflecting across the x-axis? Well, duh. Absolute value means we're always positive. So as B increases, we get stretched vertically, right? Or you could say we get shrunk horizontally, and that gets really confusing. So here, let's go ahead and make the generalization. Okay, so, and I'm going to erase, give myself some room. Let's talk about horizontal stretch and shrink. Okay, so when B is greater than 1, that's what we call horizontal shrink. Okay, so this means we're being stretched horizontally, right? Or shrunk horizontally. And we see, right, we're getting skinnier, so that means we're getting shrunk horizontally. Stretch happens, on the other hand, whenever B is less than 1. Okay, and again, we're talking magnitude, right? And I'm an idiot. So horizontal stretch happens whenever B is in between 1 and 0. Okay, so again, let's say B is 5.2. Well, duh. We have horizontal shrink. Whenever B is in between 0 and 1, we have horizontal stretch. We're being stretched horizontally. Yes, I know this is really confusing, but you'll get used to it. Okay, and then now let's talk about C. So C shifts us either right or left. And when we're adding, we go to the left. When we're subtracting, we go to the right. Well, you're probably thinking, well, duh, that's a positive 4. Wouldn't that be plus? The answer is no. This is x minus 4, right? So that shifted us to the right by 4. However, if I do x minus negative 4, right, that puts us at negative 4. X minus negative 4, that would be a double negative, which means I would have x plus 4. Okay, so that goes back to our generalization that we made a second ago, right? If we're adding, we go to the left. When we're subtracting, we go to the right. So when we added 4, we went to the left by 4. When we subtract 4, we went to the right by 4. And it's more intuitive with the vertical. So when I add, I go up, right? So plus 6, I went up 6. If I wanted to go down 6, I would subtract 6. So you get the idea. Okay, so that does it for this video. Transformations are much simpler than you would think, and they end up working pretty much the same across all the function types. Um, we'll see more of it as the year goes on. If you have any questions over any of this, shoot me an email. Otherwise, come and see me. Goodbye.